Okay, this is for your protein synthesis lab. Every group has one of these, which is a ribosome master sheet. You will have 20 amino acids, and these are anticodons, and this is the amino acid on tRNA molecules, and you will each be given a strand of mRNA, and every group strand is different. You will place the strand of mRNA on the chart, the ribosome, so that you can read the first codon is AUG. There are 2 landing sites on the ribosome, and we need to land the peptidyl tRNA binding site. So I need to find the anticodon of AUG, which is UAC. So we have codon on the mRNA, anticodon on the tRNA. Now I need to read the second codon. So the codon is UGC, so the anticodon would be ACG. And that goes on the aminoacyl tRNA binding site. So these are kind of like 2 landing sites on an airport. So now my airport is full. So I need to connect these amino acids, and in the real world, the ribosome does this in a fraction of a second. We are going to have to do this the old-fashioned way, and we're going to have to tape them together. Okay, now the tRNA is used and it goes away, and the ribosome now needs to move 1 codon down. So I still have this tRNA molecule with 2 amino acids. Now I need to read the third codon, UUU. So the anticodon is going to be AAA, and now my airport, my ribosome is full. So now this tRNA molecule, before it leaves, it's going to have to get rid of its amino acid, and then they're going to go to this next amino acid, and they're going to tape together. So now we have 3 amino acids. Now we go along, the ribosome moves down to read the next codon. Codon is CAC. So GUG will be the anticodon, and now my ribosome is full again. So I have to take all of the amino acids from this tRNA molecule, and I have to connect them to the next one. Okay, and I'm going to continue to do this until I run out of strand. So this is going to, right here, I've now exposed the next codon is AAU, and its correct anticodon is UUA. And I put that on my ribosome, and now it's full again. So this tRNA molecule is going to be kicked off. We're going to remove it. Whoops. And we're going to transfer it to the next one, and we're going to tape it together. Okay, so now we need to move again. Okay, so I've exposed the next codon, which is ACG. The anticodon would be UGA. UGC. Wow. UGC. I made a mistake, guys. Sorry. So UGC is the correct anticodon. And now this has to be moved. It has to be kicked off so the ribosome can continue working. So we're going to take off the amino acid. We're going to do this. And we now are ready to read the next codon. So everything moves. And we now are reading AAG, which is UUC. And the ribosome is full again, so this tRNA molecule is going to leave, and it's going to leave its amino acids behind, and we have reached the end of our chain. So when it reaches the end, the ribosome separates, the last transfer molecule gets cut off, and now, ta-da, we have a protein. Of course, the cell does this in less than 2 minutes to up to 500 amino acids long, and we did this with only 7.